So let's very quickly recap and then move to important topics about rectangular coordinates and how these are related to functions. So if we try and grasp the prior knowledge, we have four quadrants. If we divide the plane with two lines, there are four parts. This is called first quadrant, second quadrant, third quadrant, and fourth quadrant. This is horizontal axis, this is vertical axis. In this one, both x and y are, if this is x and this is y, both of them are positive. In this one, x is negative, y is positive. Here both x and y are negative. And the fourth one, x is positive while y is negative. So what does the horizontal axis mean, or what is the vertical axis mean? These could be the independent, usually, as we designate these axes as the independent variables on it, and this is mostly for the dependent variables on it. So wherever we have a point, it would have ordered pair. The x-axis value would be the first one, let's suppose it is a, and the second one over here is the value on the y-axis as b. It could be anything in any of these quadrants, and this is called ordered pair. Ordered pair is to designate that the two are always connected and they would always be written this way. So wherever we have a two variable equation, we can solve it. And how do we solve it? We need to have values for both x and y, and in single variable equation, you need only one value of the variable and then we can solve it. But for a two variable equation, we would need two values for both x and y to for a equation to be true. For a typical equation, let's say y is equal to 3x minus 5. We can have multiple values for x and corresponding values for y, which is 3x minus 5, and then we can formulate the ordered pair. So let's say we have minus 2, and if you plug this into this one, this would have 3 into minus 2 minus 5. It turns out to be equal to 6 and 5 minus 11. So the ordered pair for this particular case would be minus 2 minus 11. Similarly, if we have 0 for x, this would be 3 times 0 minus the same thing, it would be minus 5. So the ordered pair in this case would be 0 minus 5. And for example, if we have 2, 3 times 2 minus 5 would turn out to be 1. So the ordered pair would be 2 and 1. We can go on and on for like this, but the thing which I am trying to depict here is that we would have for x and y axis, if we have minus 2 somewhere over here, then minus 11 would be somewhere here, for example, and for 0 and the second point, 0 and -5, it would be 0 on this line, and somewhere in here for 0 -5, and for 2 and 5 it would be somewhere over here. So we can, if we had done it precisely, it would have a straight line. Should have used a scale instead, but we can extrapolate that. So all in all, it would be a straight line, and we can designate the points on it, and we can also use the graph paper to evaluate what are the points. For all those points, when the line is cutting or intercepting x-axis, is the intercept for x-axis, and for unknown points we can also calculate graphically, and that particular value of the point, the order pair would satisfy our original equation. This is very important for our system to work, but if you consider this is a straight line equation, this is a linear equation in x, we may have some equation such as x square plus 4x equal to y. For that particular case, we would do the same thing, x and xy, and it could have 4x, it could have 5x, it could have 6x, but in all those cases we could have 2x squared, it could have minus 2x squared. For all those values of -2, -1, 0, 1, and 2, would have some values for y, and then we can have the values of xy, the ordered pair. For this particular case, when the x square, the polynomial is in two variables, and we have y is equal to -2x squared plus 5x, so this is technically -2x squared plus 5x minus y equal to 0. This is the equation in two variables, but the left hand side has a degree 2 and the leading coefficient -2. So in that case, the function would be something, if we plot it, I'm just coarsely plotting it, it might not be correct, but the idea would be something like this. Because of the we would cover this coefficient later on, but if we go through the exercise, I would love it if somebody can do that. For brevity of the lecture, I'm just not doing it. Let's say if I do it for 0, it would be 0 here and 0 here, so for it is turning out to be crossing 0, 0 here. And if I use 1, this is -2 plus 5, this turns out to be 4, so this would be 1 and 4. And for -1, this would be -2, -2, and no, this is -2 and plus 5, this would be 3. And for -1, this would be -2, -5, it would be -1, -7. Because I'm looking through the camera, so I couldn't see it properly. For example, if we have 10, this would be -200 plus 50. This would be -150 for y and 10 for x. So these are the 2 points, and if we just go through all these points, and we can have this drawn up. For a pro tip, if we have plus any number c, that means the same graph would be translated up or down based on the value of c. For example, if it is 2, this would have 2. If it is -2, it would start from here. So the vertex or the this point of the parabola would start from here. So if we go to understand, if we try to understand the type of the functions, we can have it as real if we have all those values, all those exponents in control. We have it as a polynomial if the powers of all the x, if the variable is x, x power n, another coefficient for the variable with power x n minus 1 is this one, and then this goes on and on. If all these are integral, then we will have a polynomial. If we have fractional, then it would not be a polynomial at all. But the thing which is more interesting is we can graph all the equations, and all these equations can be inferred from a graph.